not so long in one of our classes. If you can remember what I'm saying, please just react. Okay, about with me, you alone, any other person.
This call is now being recorded.
Then
This call
Golden,
is
what
now
about you?
taking notes.
Can you record the things I'm talking about? Melody, what about you? It's only about me that signified that she can recall. Because I
I was not
wouldn't
in the
really.
class.
Okay, you were not in the class. Okay. And that makes the whole thing. That's why missing a class is um very, very bad. Now, let me try to see how I can just lay a little bit of the background for what I want us to do today, because basically what I want us to do today is to solve problems that involve circuit diagrams. So when you be given circuit diagrams and then you'll be asked to find current, find this, how much current flows through the circuit, how much potential difference runs through the circuit, and then this and that, how much current flows through a certain resistor. So let me just do a quick recap on few things. Now, according to Ohm's law, that's the first thing I want us to look at. Ohm's law, I won't write the law, I'll just write the equation, but I'll state the law for you. Ohm's law states that the currents flowing through a metallic conductor, I said, if you were in the class, you can recall what I'm saying. The current flowing through a metallic conductor is directly proportional to the potential difference across its ends, provided that temperature and every other physical quantities are kept constant. That is just Ohm's law. And if we are to put Ohm's law into equation, what Ohm's law is saying is that I varies directly with V. That's all. At constant temperature and every other physical quantities, I varies directly with V. And then, of course, in mathematics, anytime you see this symbol of proportionality, it has to be taken off by bringing in a constant. If I'm to change this to a quality sign, we have to bring in a constant known as constant of proportionality. So if I do that right here, we'll be having that Ohm's law, I is equals to V all over R, where this R is called resistance. So this is Ohm's law here. This is Ohm's law here. That I varies directly as V. And if I'm to write this equation in straight form or in another way around, I can say that V is equal to IR. So either of these is Ohm's law. Where V, don't forget, where V is my potential difference. Potential difference in volts. So the unit of potential difference is volts. Current, I, is my current in amperes. Current in amperes. So the unit for current is amperes. It has a symbol A, and then my R is resistance in ohms. Resistance in ohms. So the unit for resistance is ohms, and this is a symbol, ohms. All right. So this is just a recap on what we did on Ohm's law. So you can just take notes just in case you were not in the last class, and then so that everything we'll be doing, it will only make sense if you understand the basics. Now, another thing we talked about that is important for this class is how to calculate resistance when they are in series or parallel, all right? And then we said for resistance in series, resistors in series, I said that resistors are in series when they are connected end to end. I'm doing this quick recap so that everybody can benefit from the class. The resistors are in series when they are connected end to end. How do I even mean end to end? If I have a resistor, this is a symbol of resistor here, something like this. So let's say I have a resistor, I have another resistor, perhaps let me even make it 3. I have another resistor like this. So all these are resistors. Now, when I say connected end to end, meaning that I'm going to join this leg to this leg, then I join this leg to this leg. So this is end-to-end connection, such that the leg of this resistor at the end and this other one are the ones that runs into the circuit. Let's say I have a circuit like this. If I'm to connect this to a battery, this resistor to a battery, this battery has a potential difference there, has an EMF in volts, which determines the potential difference. Current is going to be flowing through the circuit in this direction. You see that? So this symbol here, this is what I mean by resistors connected in series. All right. So take note, end-to-end connection is called series connection. End-to-end connection of resistors is called series connection. And it's very, very important. Let me take off the whole diagram. This is basically what I need. All right. But have it in mind that many a times you will see these resistors connected in their numbers into a circuit diagram. And you have to be the one to spot out what mode of connection is this. Are they in series or are they in parallel? All right. And then I said, if resistors are in series, that the total resistance, otherwise effective resistance, is given by this equation, that RT equals the sum of the individual resistance of those resistors. So R3 plus, I keep on adding depending on the number of resistors. In this case, I have this to be my resistor 1, I have this to be my resistor 2, I have this to be my resistor 3. And each of these resistors has resistance. So if I ask you, and the values will be given to you in the question. So if I ask you to find the total resistance flowing through these resistors in series, all you need to do is to add up all the resistance of those resistors one after one. So you add one, assuming this was 2 ohms, let's say this is 2 ohms, then this is 3 ohms, then this is 4 ohms, and then all of them are connected like this in series, and then you ask to find the total resistance. It becomes 2 plus 3 plus 4, and everything here will give us 9 ohms. So this is the total resistance of these resistors if they are connected in series. So take note of that. That for series connected resistor, what we do is to add them up one after one. Their resistance is one after one. But also, if I have these resistors connected in parallel, if I have them connected in parallel, resistors in parallel, if I have them connected in parallel, how do I mean parallel? So let's say this is a resistor. Let me draw it this way. Let me draw another this way. Let me draw another like this also. So I'm using 3 resistors for the both examples. All right. Now, when we say parallel, it means that all the legs of these resistors are being connected one at one end. All the legs at this end is connected at a point, such that from that point there, I can have an outlet that runs into the circuit. Now, I also have everything here connected at this other side, such that from this point here, I have an outlet that will run into the circuit. All right. So anytime we have resistors like this, such that they are connected side by side, in which in each side we have all the legs being joined to a certain point, where we can now pick them down to the load, to the circuit. We say that these resistors are connected in parallel. And if resistors are in parallel, their total resistances, let's say I have this one, let me call this R1, let me call this one here R2, let me call this one here R3. And these resistors, I'm to find what exactly is the total resistance of this resistor. How do I find it? The total resistance, otherwise the effective resistance, is given as 1 all over RT equals 1 all over R1 plus 1 all over R2 plus 1 all over R3. So this is how we can calculate the total, and then if there are more, you keep on adding. All right, so it doesn't mean it has to stop at 3. It can be 2, it can be 3, it can be 4, it can be 5, it can be any number at all. It all depends on how big or how large that circuit is. All right, so just have it in mind, if they are connected in parallel, so you have to do the sum of their what? Inverse. And when you're done, remember the total resistance is also what? Inverse. All right, so when you're done adding up the inverse of these resistances, when you're done, you have to take the inverse again for you to get backwards the total resistance. What do I mean by that? Now let's assume this resistor here, let's call this one here, let's say this is 2 ohms. This resistor here is 2 ohms. Then this one here, let's call it 3 ohms. Let's call this one here, let's say this one is 4 ohms. All right, so I'm just trying to give label each of these resistors. So I give us an example. So this is 4 ohms. 4 ohms is the last one. Okay, so this is 4 ohms. Don't mind the diagram, it's looking small, but I just hope you understand. Now if I want to add up this, find the total resistance of these resistors, how do I do that? So I have to do that, I have to follow this method, that 1 all over RT equals 1 all over 2, which is my R1, plus 1 all over 3 plus 1 all over 4. This is exactly how I do it. Then I have to add up these. How do I add up these fractions? LCM of the denominators will give me 12. 12 divided by 2, that will give me 6. And 6 multiplied by 1, that also gives me 6. 12 divided by 3, that gives me 4. And 4 multiplied by 1, that equally gives me 4. 12 divided by 4, that gives me 3. And 3 multiplied by 1, that also gives me back 3. So if I add up everything here, I'll be having 6 plus 4, 10 plus 3, that will give me 13 all over 12. So it means that my 1 over RT, sometimes students mix it up and think that this is total resistance. No, remember what you find is 1 all over RT is equal to 13 all over 12. So therefore, RT alone becomes the inverse of 13 over 12. And the inverse of 13 over 12 should give us about 12 all over 13 ohms. So if you press this in calculator, you can get what it is in fraction. So this is how we calculate resistance when they are connected in parallel. It's as simple as that. So remember, I just brought our knowledge back, or just try to remind us what we've done or the things we've discussed earlier in one of the classes. We've talked about Ohm's law. I've just reminded us what Ohm's law is all about. And then we've also talked about resistors in series. I just reminded us once again. And now resistors in parallel. All right. Now, take note that if resistors are connected in series, the current flowing through the resistors are the same. Don't forget that. Anytime you have series connected resistors in series connected resistors, once they are in series, the same amount of current that flows through resistor A flows through B, flows through C. All right. But when they are in parallel, no, you have to get each of the resistor has its own current. That is it. So when they're in parallel, you can be asked to find the current flowing through a certain resistor when they are connected in parallel. All right. So have it in mind, in series, the same current flows, but in parallel, different current, the current value will be different for every what resistor. And don't forget, the more resistance a resistor has, the less current it can what that can flow through it. Don't forget that. So if a resistor has a higher resistance, so higher resistance equals lesser or lower current flow. So if the resistance is low, current will be high. If current is high, it means that the resistance is low. And just like that. Okay, I think this is just a quick recap on what we did. And basically, from what I've said, that is all that is needed for us to navigate problems on circuit diagrams for today's class. Now, let's take a question. Every question that we'll be doing here, all of them strictly are past questions. We were all sorted out from past questions. Now, you can take down the question, calculate the current. Calculate the current in the 3 ohm resistor shown in the diagram below. Calculate. This is, let me call it example. is a calculate the current in the 3 ohm resistor, in the 3 ohm resistor shown in the diagram below. Shown in the diagram below. So how do I calculate the resistor? The current. Let me draw the resistor first. Now, I have resistor like this. I have another one like this. I have another one like this. So, each of them, they were connected in parallel. I'm trying to sketch a circuit diagram. This is how the circuit diagram looks like. I'm not so good in sketching, but I really hope this is clear enough. All right, so this one was labeled 2 ohms. This one was labeled 3 ohms. This one was labeled 4 ohms. And they told us that the current flowing through this resistor, they just put a symbol like this. It puts an arrow telling us the direction of the current flow, that the current there is 13 amperes. So this is the question. And now they want us to find the current flowing through resistor at the center, which is 3 ohms. So how do I solve this question? First of all, I need to find the potential difference that is producing that 13 amps in that circuit. I need to calculate it. Even though they didn't show us a complete circuit diagram, but of course, for 13 amps to flow is already connected to either a battery or any cell. All right, so like that. So let's calculate the current flowing through resistor at the center, which is 3 ohm resistor. But before we do that, we need to find the total resistance of these resistors. That's the first thing to do. We have to calculate total resistance of this resistor. So since they're in parallel, recall. So for resistors in parallel, I'm going to do that 1 all over RT is equal to 1 over 2, which is the first one, plus 1 over 3, plus 1 all over 4. That's what I have. Now, this is even similar to this, just more like the example I just gave right now. So let's move on. So the LCM is 2, 3, 4, that's 12. 12 into 2 is 6, and 6 times 1 will give us 6. 12 into 3 is 4, 4 times 1 will give us 4. 12 into 4 is 3, and 3 times 1 will give us 3. So everything here becomes that my 1 all over RT is equal to 13 all over 12. So 13 all over 12, if I take the inverse, my RT, which is the total resistance, becomes the inverse of 13 over 12, which is 12 all over 13 ohms. So this is the total resistance inside this circuit. All these 2, 3, 4 produces a total resistance of 12 over 13. That's less than 1 ohm. You see that? So it's already less than 1 ohm. So from what we have right here, let's now calculate the potential difference of the circuit using Ohm's law. From Ohm's law, we have that V is equal to IR. All right. And from the diagram, let's go back to the diagram. They told us that the current flowing through the circuit, you can see that clearly, 13 amps. All right. 13 amperes is a current that flows through that circuit. So what I'm going to do is to represent the current with 13 amperes, represent my resistance with 12 all over 13. So this implies that the potential difference V is equal to 13 multiplying the resistance, which is 12 all over 13. See, not changing it to decimal helped us a lot. So we can cancel out 13, go with 13. It means that the potential difference V is 12 volts. 12 volts. Therefore, we can now know the current flowing through the 3 amps resistor, the 3 ohm resistor, having known the potential difference flowing through the circuit. How do I achieve that? Still the same word, Ohm's law. For current flowing through resistor 3, which is the 3 ohm resistor flowing through 3 ohms resistor, I can say that my I3 is actually V, should I call it I3? Because it's 3 ohms. Okay, let's leave it like that. I3 is equals to V all over R3. So please, the 3 there simply indicates simply means that we are talking about resistor with 3 ohms. That's what the symbol means, please. Remember, what am I even doing? Remember, V is equals to IR. For those of you that may be confused, what am I doing? It means that if I make I substitute formula, I becomes V all over R. That's exactly what I did here. So from my equation, the point I'm trying to make is that the current flowing to resistor 3, that's what I mean by I3, is equal to V all over the resistance of that 3 ohm resistor. All right. So if I do that, I have that I3 current flow through that resistor is equals to 12 volt divided by what? 3 ohms. You see that? And if you divide 12 by 3, that will give us 4 ampere. So the current that is flowing through that resistor of 3 ohms is actually 4 amperes. That's how we do it. So if you were asked to find the current flowing through the 2 ohm resistor, we can do that I2 becomes what? 12 all over 2. And that will give us 6 ampere. If they say current flowing through the 4 ohm resistor, I can equally do that I4 becomes 12 all over 4, and that will give us 3 ampere. So the current flowing through the third resistor is 4, the 3 ohm resistor is 4 ampere. Current flowing through the 2 ohm resistor is 6 ampere. Current flowing through the 4 ohm resistor is 3 ampere. And if you add up everything there, you see that we are going to get 13 ampere, which is the total current that is flowing into the circuit. I'm sure that makes sense enough. Please, do you understand? I need responses. I'm asking, do you understand the explanation? Do we move on? No one is saying anything. I'm used to the fact that you guys always sit at the back end with zero contributions, but that doesn't make sense all the time. So please, I ask again, do we understand this simple question that I just saw? Does anyone have any question at all? Something you didn't get, or you can just bring it up. Or if you understand, I would like us, no reaction, just speak. Okay. You guys don't want to say anything. Golden, do you understand? Maybe I have to call names. Golden Melody Obaomi.
Alafonso.
Melody and Obaomi. Okay.
Sir,
All right. Let's move on. Next question.
please shift your screen downward, please.
How do you mean downward?
Yes. Please shift it again.
This is the last side. This is the last thing we did. Okay, so we're going to look at the second question. The second question says we should calculate the current flowing through the circuit diagram. So we have a circuit diagram, which I'm going to put down here. So they say we should calculate the current flowing through that circuit diagram. Okay, so how do we do that? Let me put down the diagram before. We have a circuit diagram this way. I'm trying to sketch the diagram. I'm sure by now we should have understood some of these component symbols. What I'm trying to sketch now is my cell. It's called a cell. And then I have another resistor connected this way. Okay, this is how the circuit looks like. It looks like we have here to be 2 volts. We have 2 volts here. Here is 2 ohms. Here is 2 ohms. And this is 4 ohms. So that is it. So this is basically what we have. And then, of course, the current will always flow from higher potential. This is what we have. This is the direction of the current flowing this way. And then the question says we should calculate the currents I flowing through the circuit. They say calculate the currents I flowing through the circuit. Okay, so how do we solve this question? Having known the diagram. Now, if you observe the question, clearly you can see that I have resistor. First, this is my R1. Let me call this R1. Let me call this R2. Let me call this R3. So, firstly, the first thing to observe is that R1 and R2 are connected in series. You can see that that is an end-to-end connection. So, R1, R2 are connected in series. But after doing that, you can now see that R1, the sum of R1 and R2 is in parallel with R3. You understand that? So if I get the effective resistance for R1 and R2, anything I realize from there is going to be in parallel with R4, because R4 is actually in parallel with these 2 resistors right here. So what do? I have to first of all calculate the effective resistance for the one in series. So I can start by saying for resistors in series, or I'll say R1 and R2, having labeled them, R1 and R2 are in series. So if they're in series, it means that their total resistance, RT, becomes R1 plus R2, which is just 2 ohm plus 2 ohm, and that will give us 4 ohm. So this is the total resistance for the 2 resistors that are in series. But now, R3 is in parallel with the sum or the effective resistance of R1 and R2. So I can say R3 is in parallel with R1 and R2. So what that means is that since I've gotten the effective resistance for R1 and 2, it means that I can now calculate them in parallel, that 1 over RT becomes 1 over 4, which is the effective resistance for R1 and R2, plus 1 over 4 again, where this 4 is the resistance of the R3 right here. Look at it. R3 has 4 ohms. And coincidentally, when we added R1 and R2, we also got 4 ohms. All right. So if I have to solve this clearly, you can see that the denominators are the same. So we add up the numerator. 1 plus 2. 1 plus 1 will give us 2. And we have 2 over 4. So it means that 1 all over RT is actually 2 over 4. And if you take their inverse, therefore, our RT becomes 4 all over 2. And then what is 4 all over 2? That is actually 2 ohms. So the resistance of those resistors connected there is basically 2 ohms. Now they said we should find the current flowing through the circuit. How do I find the current? To solve for the current, we use Ohm's law. To solve for current, we can recall that V is equal to IR, or that our I, which is current, is equal to V all over R. So since you are looking for current, we can say that I becomes V. What is V from the diagram? V was given in the diagram as 2 volts. You can see that. So V is just 2 volts. So if I have to use that, we'll be having that V, which is 2, divided by the total resistance of everything we found, which is also 2. And then the current flowing through the circuit, 2 over 2 will give us 1 amperes. So the current flowing through the circuit is simply 1 ampere. So let me write the ampere. Very well. And this is how to solve questions of this kind. So when you have circuit diagrams like this, your job will be to check what mode of connections are those resistors connected, then resolve them into their total effective resistance. And when you're done, then you use Ohm's law in solving the problem, just like I have done. Okay, so we have another question right here. Another question. So what I want us to do, maybe in our next class, which may eventually be the last class, we'll try and solve questions involving internal resistance. I want us to master electric current or electric circuit because it is an aspect of physics you must expect in every exam. It comes out both in theory and in practical. Sometimes, in fact, there is no term or no section, no year you don't see practicals on electric circuit. It's true we can't do practicals right now, but if you can understand the calculation, it makes the whole thing easier for you. The next thing you have to do is to learn how to plot your graph, and that is just very, very simple. You can always learn how to do that. Okay, so let's look at a question. There's a question I'm seeing right here. Now they said a battery of EMF E and negligible internal resistance
Sir,
supplies the current. Yes, I'm listening. I'm listening to you about me.
why do you twice?
What? Why did I do what?
Write 1 over 4 twice.
It means you were not following my explanation. Now, the reason for that is because, listen, for the first resistance, we first of all calculated R1 and R2, we said are in series. And since they are in series, I have to find their total resistance. And how do you find their total resistance? By adding them up, just R1 plus R2. And when I did that, I got 4 ohms. And then I said here that R3 is in parallel with R1 and R2. Look at this diagram. You can see that these two here, these two, R1 and R2, came here. One, the one of the leg came here. This R4 also, R3, which is 4 ohms, also has a common meeting point here. Then this other side, I have 2 points here. So you see that. So the sum of these two resistance here is actually in parallel with R3, which is 4 ohms. All right. So how do we add up resistance in parallel? I have to follow the formula R1 over R2 equals 1 over R1 plus 1 over R2. And when I did that, since the sum of R1 and R2 is 4 ohm, I have 1 over R4. And also, the resistance for R3 is 4 ohms. That's why I have 1 over R4 twice. And then when I did that, I was able to get 2 ohms. And then applying Ohm's law, I got 1 ampere as a current flowing through the circuit. Does it make sense about me?
Yes, sir.
Okay. Now, the next thing we want to do, still on circuit diagram, the question says that a battery of EMF E and negligible internal resistance supplies current I to combination of two resistance R1 and R2 as shown in the diagram. Oh, this is an expression. Okay, let me write out the question. This one, the question, the way it is more like an expression. Our answer is going to be in terms of expression. So they said a battery of EMF means electromotive force. We talked about that in the class when we discussed all of this. With EMF E and negligible internal resistance, supplies a current. Supplies a current I to combination of two resistances R1 and R2 as shown in the diagram below. Now the question says we should calculate the current flowing through R2. Calculate the current flowing through R2. So this is a question. A battery of EMF E and negligible internal resistance supplies a current I to combination of two resistances R1 and R2 as shown in the diagram below. So this is a diagram here. Let me draw it exactly the way it is right here. So I have a circuit like this. Okay. Okay. I'm trying to sketch the circuit, and then at this point, I have the battery being connected, and then the battery which has an EMF E of course, we deliver a potential difference V throughout the circuits. So the current will flow in this direction, and they call this place R1, and then they call here R2. And then this is actually what the circuit diagram asks is. They want us to find the current flowing through R2. For us to find the current flowing through R2, firstly, we need to understand what is the potential difference in this circuit. So what's the value of V? Because they want us to find our current in terms of an expression. All right, so we should derive an expression that tells us the current that is flowing through the circuit. So before then, you can see that R1 and R2 are connected in parallel. And since R1 and R2 are in parallel, we are going to add them up in parallel. So for resistance in parallel, or resistors in parallel. So we can find their resistance by using the equation 1 over RT equals 1 all over R1 plus 1 all over R2. So in this case, how do we add up these fractions that are not letters and not numbers? So what's the LCM of R1 and R2? That will give us their multiple, which is R1 multiply R2. So this is basically the LCM, R1 multiply R2. If you use that to divide R1, R2 multiply, divide R1, I have R2 left. R2 times 1 is going to give me R2 plus, if I do the same thing here, R2 cancel out, I have R1. R1 times 1 will give me back R1. So I have that my 1 all over RT equals R2 plus R1 all over R2 R1. So clearly, if we are to get RT alone, therefore we can then say that our RT become the inverse of this expression, which is R1 R2 divided by R2 plus R1. So this is the total resistance that is flowing through, that is connected to the circuit. So having added R1, R2, this is what I have. And from here, we can check from Ohm's law. From Ohm's law, remember, if we know the potential difference flowing through the circuit, it is easier for us to know how much current that is flowing through a given resistor. We can always do that, since current is actually V all over what? R. Now we found the R. From Ohm's law, we have that V is equal to IR. If V is IR, we found our RT, which is the R total as R1, R2 all over R1 plus R2. So we have that. This implies that the potential difference flowing that circuit can be given by this equation, this expression, that V equals I multiplying, so let's put that in brackets, R1 plus R2, no, not a plus, R1, R2, so R1, so no need for the bracket even. So I have I R1 R2 divided by R2 plus R1. So this is basically the potential difference, as the expression telling us how much potential difference that is flowing through that circuit. So from here, we can then find the current that is flowing through the 3 ohm resistor, the not 3 ohm please, the R2. Remember, they say, the question says, let's go back to the question. They say we should calculate the current flowing through R2. So let's find the expression for the current in R2, having known the V. And also from Ohm's law, so solving for current flowing through R2, recall from Ohm's law, current in two, let me call that I2. We have that our current in 2 will simply be the potential difference V divided by the resistance in the 2. So this means that I'll be having that. This implies that the current in the 2 ohm resistor, I2 becomes V, which is simply I R1 R2 divided by R2 plus R1. So everything I have here is my V divided by R2, all right? Remember, I2 is V all over R2. So this is my V. So let me use the division symbol, division divided by what? R2. And of course, in division, whenever you have division, you want to change to multiplication, it becomes you can flip, you then flip the fraction, right? So it means that we can have that I2 simply becomes I R1 R2 all over R2 plus R1, then multiplying 1 all over R2. So you see that the moment I change it to multiplication, it became the inverse. And clearly, I can use R2 and cancel out R2 here so that I'll be having that the current flowing through the 2 ohm resistor is equal to what? To R2, not to ohm, please. There's no equation, no value given. It's given as I R1 divided by R2 plus R1. So this is actually the expression they want us to find. So this is the expression that tells us how much current is flowing through resistor 2. And that's exactly what I did right here. Any question, please? Now, the questions on this topic are very, very, very numerous. We can't finish them, not even in this class. We can't even do more. We can't even do anything. The questions are very, 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 very many. So, but what I want us to do is, having seen the examples, we should try and see how much we can do for our own self. We should try and see how much research we can make, and then the stuff we can do basically for our own self. So I'll just put down an assignment on the diagram on the board, and then the assignment says you calculate the current that flows through 1 ohm resistor. The current that flows through 1 ohm resistor. That's exactly what we are going to find right now. So I'll give you an assignment. Our time is up, but then we can do this assignment on our own. When you do it, maybe the next class, you can ask. I always do say, if you feel you have an issue, maybe from now to whenever you're writing your exam, I heard your exam is on the 1st. I wouldn't know if I'm correct anymore. But let's say you are writing exam on 1st. If you have any issue in your physics and then you feel you need clarity, you can always reach out to me on WhatsApp. My number is on the group chat. You can always reach out to me. But before then, this is an assignment for you, and I want you to try it out by yourself. So I have a circuit diagram. So this is a resistor. So when you download this video, you can always see, go back when you go back to the video after the class, everything you may miss or you may have
I don't,
missed. You don't what?
I say I don't see your video, sir.
You don't see my video. I don't know. Were you the one that complained that the last time? Because I was told that some students said that I don't upload videos. I told them if the videos don't show, it means it's from their own end, because I upload every video, as I always do tell people in class, every video. But I think they are working on that now. So maybe from today you can go back again and check. They didn't know all this while. And me, I didn't know that the videos, I keep on saying it. No one has ever told me that I've not been seeing the videos. It was the day someone brought it up, I have to tell them I've been uploading every video from the day one till now. So please, you can always go back and check through the videos. I think the things have been rectified now. I want to believe that. Okay, so what I'm drawing is exactly what we have on the diagram. Okay, the next thing would be to label. This is my 12 volts, which is the potential difference flowing from that cell. So this one here is 3 ohm. This one here, everything is 3 ohm there. Let me write them on the outside so it doesn't look too small. So this is 3 ohm. This one is 3 ohm. This one here is 3 ohm. This is also 3 ohm. So the three resistors there are all 3 ohms, 3 ohms, 3 ohms. Let me write this. And then this one right here is 1 ohm. It's 1 ohm. Now, the question says calculate the current flowing through the 1 ohm resistor. So let me write it out. Say calculate the current flowing through the 1 ohm resistor. Okay, so that is that for the class. In our next class, we'll look at more questions on this. Perhaps I may start by doing correction on this very well. But I want to believe that every one of you can try it out by yourself, and then other questions also to help you prepare on this area, even for your exam. So ask me your question before I leave. That's our time is up. But the question is calculate the current that flows through the resistor, through 1 ohm resistor. Does anyone have a question? No question. I want to believe that the class was beneficial, and then if that be the case, we may just have to draw the course to a close. We'll see you in the next class on Tuesday. Have a great evening, everyone. All right. Thank you, allowing me.